I've written this article to explain why Kotlin is better than Java for Android development. Java and Kotlin are two popular programming languages that are often pitted against each other. They are pitted against each other as both can be used for Android programming. Both have their pros and cons, but which one is the better choice for your project? I've written this article to explain why Kotlin is better than Java for Android development. Kotlin is a statically typed programming language for the JVM, Android, and the browser. It is a fully open source language with great support from JetBrains. Kotlin is a great language for modern programming. It has a concise syntax that is easy to read and write. It also has great tooling support from JetBrains. Kotlin is fully interoperable with Java, so you can use all the existing Java libraries in your Kotlin code. If you are looking for a language to write modern, concise, and safe code, then Kotlin is a great choice. Here I will list the features that Kotlin has that Java does not have. First one is Lambda expressions. Lambda expressions are a powerful tool in Kotlin that can help to make your code more concise and readable. Let us look at what Lambda expressions are and how you can use them in your Kotlin code. Lambda expressions are anonymous functions that can be used in the place of a named function. They're often used in conjunction with higher order functions, which are functions that take other functions as arguments. Lambda expressions can be used to simplify code that would otherwise be verbose or difficult to read. Inline functions. An inline function is a function that is compiled inline with the code that calls it. This can improve performance by reducing the amount of time spent calling the function. In Kotlin, inline functions are marked with the inline keyword. When an inline function is called, the code of the function is copied and pasted into the code that calls it. This can improve performance, but it can also increase the size of the generated code. Inline functions can only be used if they are declared in the top-level function or a member of an object. They cannot be used in local functions or anonymous functions. Inline functions can be used to improve the performance of code that calls them frequently. They can also be used to avoid the overhead of creating a new object for each function call. Extension functions. Kotlin extension functions are a great way to add new functionality to existing classes without having to subclass or modify the original class. Extension functions are declared as top-level functions in a file with the receiver type specified before the function name. The receiver object is the object on which the extension function is invoked. Extension functions can access the public members of the receiver object, but they cannot access private members. This is like the way that subclass methods can access the public methods of their superclass, but not the private members. Null safety. Kotlin's null safety is a great feature that can help prevent null pointer exceptions in your code. When a variable is declared as non-null, it cannot be assigned a null value. If you try to do so, the compiler will throw an error. This is especially useful for variables that are used to hold references to objects. Another great feature of Kotlin's null safety is that it can help you avoid null checking code. Smart casts in Kotlin are a great way to improve the readability and safety of your code. By using smart casts, you can eliminate the need for explicit type checks and casts in your code. This can help to make your code more concise and easier to read. Smart casts are particularly useful in situations where the type of an object is known at compile time but can change at runtime. String templates. Kotlin string templates are a simple and convenient way to create and manipulate strings. They provide a powerful and expressive way to embed variables and expressions into strings and can be used in both inline code and in string value properties. String templates are declared with a $sign followed by a curly brace. You can use any expression inside a string template, not just variable references. If you need to use a literal $sign in a string template, you can escape it with a \. Primary constructors. Kotlin's primary constructors are a powerful tool that can help streamline your code. By annotating a constructor with the @primary annotation, you can make it the default constructor that is called when your class is initiated. This can be useful when you want to enforce a particular order of initialization for your class. First class delegation. Kotlin's delegation mechanism is one of its most powerful features. It allows you to create a delegation relationship between two objects, whereby one object, the delegate, handles certain aspects of the other object's behavior, the delegating object. This is a powerful technique that can be used to achieve a great deal of flexibility and extensibility in your code. In Kotlin, delegation is implemented using a delegation pattern. The delegation pattern has several benefits. It allows you to create separate responsibilities between objects. It can be used to make your code more extensible. Type inference for variable and property types. Type inference is a process of automatically deducing the type by analyzing its usage. In Kotlin, the compiler tries to infer types for local variables, function arguments, and return values based on context. By default, all variables are non-null, with no explicit type required if an initializer is used. We can explicitly specify the type if needed by adding an explicit annotation or using question mark to prevent nullable types from being inferred from context. Type inference is a process of automatically deducing the type by analyzing its usage. In Kotlin, we don't need to specify the types for variables, return values, arguments, and properties. The Kotlin compiler can deduce nullability from context and usage. If you don't use an initializer, however, then you must specify the type yourself. Singletons. Kotlin's singleton pattern is a way to ensure that only one instance of a particular class exists in the runtime. This can be useful for things like managing database connections or other resources that are needed to be shared across the application. Singletons in Kotlin are created by using the object keyword. Once a singleton class has been created, you can access its members by using the same syntax as any other class. If you need to create a singleton that can be initialized with parameters, you can use a companion object. A companion object is an object that is associated with a particular class. It can be used to hold things like static methods or factory methods. Declaration site variants. Kotlin's declaration site variants is a powerful tool that allows developers to express their type intentions more clearly. By annotating a type with the in or out keyword, you can specify whether a type is covariant or contravariant in its subtyping relation. This gives the compiler more information about our types, which can be used to prevent type errors. Type projections. Kotlin's type system is designed to allow nullable and non-nullable types to coexist without the need for explicit conversions. However, there are some cases where the compiler is not able to infer the type of a variable. In these cases, you can use type projections to specify the type of a variable. Type projections are useful in several situations. For example, when you are using a generic type and you want to specify the type of the generic parameter, when you are using a type that is not nullable and you want to allow it to be nullable, when you're using a type that is nullable and you want to make it not nullable. Range expressions. In Kotlin, range expressions are used to create a range of values. There are two types of range expressions. Closed range expressions. These expressions include both the start and end values of the range. They are created using the ... operator. Half-open range expressions. These expressions include the start value, but exclude the end value of the range. Both types of range expressions can be used to iterate over a range of values. Range expressions can also be used with connections. Operator overloading. Kotlin supports operator overloading, which means you can define new behavior for existing operators or create new ones of your own. For example, the plus operator can be used to add two numbers, concatenate two strings, or combine two lists. Kotlin also provides standard functions for many of the common connection operations, such as contains and index of, which can be invoked using the infix notation. Operator overloading can be a powerful tool for creating expression. Companion objects. Kotlin's companion objects are a great way to store static members of a class. They are similar to Java's static fields and methods. Companion objects are declared using the companion keyword. One common use of companion objects is to store constants. For example, you might want to store a list of all the countries in the world in a companion object. Another common use of companion objects is to create static factory methods. These are methods that create instances of a class. For example, you might want to create a static factory method that creates an instance of a country class from a country code. Companion objects are a great way to store static members of a class and to create static factory methods. Data classes. Kotlin's data classes are a great way to create simple, immutable objects. By storing data classes, you can create and manipulate objects without having to write a lot of boilerplate code. Data classes are also very useful when it comes to working with databases or other data sources. By using data classes, you can easily map your data to objects and vice versa. Coroutines. Coroutines are a powerful tool for concurrent programming in Kotlin. They are lightweight threads that can be suspended and resumed at will, and they are very efficient in terms of resources. Coroutines can be used for a variety of tasks, such as executing code in a background thread, suspending a thread to wait for some event, communicating with other threads. Coroutines are very easy to use. All you need to do is write a suspending function and then call it using the launch or async functions. Below, I will list both the pros and cons of Kotlin. The pros. Kotlin is a statically typed programming language that runs on the JVM and can also be compiled to JavaScript. Kotlin is a great alternative to Java for many reasons. Kotlin is more concise than Java. This means that you can write less code to accomplish the same task, which can lead to less bugs and a more maintainable code base. Kotlin has null safety built in. This means that you can't accidentally assign a null value to a variable, which can help prevent null pointer exceptions. Kotlin is more expressive than Java. This means that you can often accomplish the same task with fewer lines of code, making your code more readable and maintainable. Kotlin is interoperable with Java. This means that you can easily call Java code from Kotlin and vice versa. This can be very useful when you need to use existing Java libraries in your code. The cons. Kotlin is a new programming language that has a lot of potential. However, there are some potential drawbacks to using Kotlin that developers should be aware of. One potential drawback is that Kotlin is not yet as widely adopted as other programming languages. This means that there is a smaller pool of Kotlin developers to hire from, and it can be more difficult to find Kotlin-specific resources and support. Another potential drawback is that Kotlin is not fully compatible with all Java libraries and tools. This means that some Java libraries and tools may not work with Kotlin or may not work as well as they do with Java. Finally, Kotlin is a relatively new language, and as such, it is still evolving. This means that new features and improvements are constantly being made, and older features may become deprecated. This can make it difficult to keep up with the latest Kotlin development and can make code written in Kotlin less stable over time. What is Java? Java is a high-level programming language originally developed by Sun Microsystems and released in 1995. Java runs on a variety of platforms such as Windows, macOS, and the various versions of Unix. Java is known for its simplicity, ease of use, and portability. Unlike many other programming languages, Java is an object-oriented language. This means that a program is built around objects rather than actions and data. Java is also platform independent, meaning that it can be run on any operating system that supports the Java Virtual Machine, aka the JVM. Java is widely used in a variety of applications, including web-based applications, mobile apps, and desktop apps. Here I will list the features that Java has that Kotlin does not have. First off, I'll start with checked exceptions. Java checked exceptions are those which the programmer must take care of. It is up to the programmer to decide how to handle them. For example, if you are writing a method that opens a file, you must catch and handle the file not found exception, which is a checked exception. Unchecked exceptions, on the other hand, are those which the programmer need not take care of. The compiler will take care of them. For example, if you are writing a method that uses an array list, you need not catch and handle the array index out of bounds exception, which is an unchecked exception. Primitive types are not classes. Primitive types are not classes in Java. This means that they cannot be used to create objects and they cannot be extended. Static members. Static members in Java are those which are associated with the class rather than with any specific instance of that class. A static member can be a field, a method, or a nested class. Static fields are created when the class is loaded and they're destroyed when the class is unloaded. Static fields are initialized to their default values when the class is loaded. Static fields can be accessed directly by the class name without the need for an instance of the class. Static methods are associated with the class rather than with any specific instance of that class. Static methods can be invoked without an instance of the class. Static methods can access static fields directly without the need for an instance of the class. Static methods cannot access non-static fields or methods directly. Nested classes are classes that are defined within another class. Nested classes can be static or non-static. Static nested classes can be accessed without an instance of the class. Wildcard types. When it comes to programming, a wildcard is a symbol used to denote an unknown or unspecific element. In Java, there are two types of wildcards: upper bounded wildcards and lower bounded wildcards. Upper bounded wildcards. Upper bounded wildcards are denoted by the symbol question mark followed by a supertype. This type of wildcard allows you to pass in a list of objects that are of the same type or a subtype of the specified supertype. For example, if you have a list of integers and you want to pass it to a method that accepts a list of numbers, you will use an upper bounded wildcard. Lower bounded wildcards. Lower bounded wildcards are denoted by the symbol question mark followed by a subtype. This type of wildcard allows you to pass in a list of objects that are of the same type or a supertype of the specified subtype. Ternary operator. The ternary operator in Java is a short way to write an if-else statement. The operator consists of three parts: the condition, the result of the condition being true, and the result of the condition being false. You can use the ternary operator to replace a simple if-else statement. However, keep in mind that the ternary operator is not suitable for complex conditions. Below I list both the pros and cons of Java. The pros. Java is one of the most popular programming languages in the world, and for good reason. Here are some of the key advantages of Java that make it so popular. Number one, Java is versatile. Java can be used for a variety of applications, from mobile apps to web applications and everything in between. Number two, Java is platform independent. One of the big advantages of Java is that it is platform independent. This means that Java code can run on any platform that supports the Java platform, including Windows, Mac, Linux, and more. Number three, Java is easy to learn. Java is a relatively easy language to learn, especially if you have experience with other programming languages. There is a large number of resources available to help you learn Java. Number four, Java is well supported. There is a large community of Java developers and a wealth of resources available to help you when you need it. The cons of Java. Java is a popular programming language, but it has its fair share of drawbacks. Number one, speed and performance. Java is slower than native languages, such as C or C++. It can take longer to execute a Java program than the program written in the native language. Number two, memory management. Java programs can use a lot of memory. This can be a problem if you are trying to run multiple Java programs at the same time, or if you are trying to run a Java program on a computer with limited memory. Number three, security. Java has had its share of security problems. There have been vulnerabilities in the Java runtime environment that have allowed malicious code to be executed. Number four, platform dependence. Java is platform dependent, which means that a Java program can only run on a platform that has a Java runtime environment. This can be a problem if you want to run a Java program on a platform that does not have a Java runtime environment. In conclusion, Kotlin is better than Java for Android development. Here's a summary of the reasons why. In May 2019, Google stated that Kotlin is the preferred language for Android development, meaning that Java will be phased out gradually. Better to hop on the Kotlin bandwagon now and be ahead of the curve. Kotlin is also more concise than Java. This means that you can write less code to achieve the same results. Kotlin is more type-safe than Java. This means that you are less likely to run into type-related errors at compile time or runtime. Kotlin has better support for functional programming than Java. This means that you can write more concise and readable code. Kotlin has better tooling support than Java. This means that you can use IDEs and other tools more effectively when working with Kotlin code. Kotlin is more interoperable with Java. This means that you can easily call Kotlin code from Java code and vice versa. I hope you enjoyed my first YouTube video. I will be posting a new video every month. I would like you guys to do the following so I can keep giving you more quality content and keep building the community. Please leave a comment and tell me the following: whether you agree with me when I say that Kotlin is better for Android development, and if you disagree with me, please share the reason as to why, and also future topics you would like me to cover. Please do not forget to subscribe to the channel, like the video, and turn on the notifications.